Hydrazine. That's a pretty cool name, not gonna lie. It's probably gonna be my running gag in the title slides. Anyways, a good starting point is to ask ourselves, what exactly is hydrazine? This is hydrazine, also known as hydrazine hydrate in an aqueous solution. At first glance it's a simple structure, and looking at its physical form, it appears to just be a clear, colorless liquid. Get closer and you may get a whiff of the scent of ammonia, hinting at the fact that it's basic in nature. Get too close and it'll have catastrophic effects on your nervous and respiratory systems. Apart from that, this stuff is versatile. Hydrazine and its derivatives have been used in just about everything, from rocket fuels and nuclear reactors to pesticides and pharmaceuticals. The reason for this is hydrazine's unique chemical properties which make it convenient to use for a number of purposes, industrially. But before we get into that, let's get into the history of this compound that gets around. Hydrazine is widely recognized as having been discovered by the German chemist Theodor Curtius in the year 1887, with Dutch chemist Labrie de Bruijn expanding on his discoveries in 1893 by producing the first sample of anhydrous or pure hydrazine. In 1907, a method for producing hydrazine was created by German scientist Friedrich Rasching. The method, appropriately named the Rasching method, called for the production of monochloramine through a reaction of sodium hypochlorite and ammonia. The monochloramine was then added to heated ammonia and allowed to react, and then distilling what remains to isolate the anhydrous hydrazine. This method has since largely fallen from use, and the generally agreed upon current method is the peroxide process, which creates fewer excess products and is generally more economical and environmentally friendly. Hydrazine was mostly ignored by scientific and corporate communities until the Germans discovered its potential as a propellant in 1937 during their experimental developments of rocket-powered fighter aircraft, using it in a mixture known as Seestoff. Seestoff went on to be used in the engines of Messerschmitt Me-163B aircraft, which were occasionally flown during the Second World War. After the Germans were defeated in the war, their findings on hydrazine were revealed to the rest of the world, leading to a newfound interest in hydrazine and its potential industrial applications, which scientists scrambled to discover. So many things. Hydrazine is used for so many things. One thing you have to understand about hydrazine is that it's extremely inexpensive to produce, and the one thing every industrialist loves to hear is cheap. Scientists from the private sector found a way to use it in just about everything. Of course, it continued to be used as a propellant in rockets and jet engines of all sorts, from NASA rockets and satellites to military jet engine aircraft. Hydrazine is also used industrially in reactions that produce gas for a number of uses. During the production of foamed plastic, a chemical reaction creates a number of gases which are then blown into the liquid plastic, causing bubbles to form, and later it all hardens into a sort of spongy, foamy texture. This is how things like insulation foam and spandex fibers are created. Another place where hydrazine is used is in gas-producing reactions in the airbags of a car. Hydrazine is one of the reactants used to create sodium azide, which is the chemical that causes the airbag to inflate. It's also used extensively in nuclear power plants to isolate plutonium metal and to keep the metal components from oxidizing. And finally, it's used in the process of producing chemicals for things like pharmaceuticals, fungicides, and pesticides. Again, with the pesticides, this class is setting me up to be a pesticide documentarian more than anything else. I've spent the last few minutes telling you all about how great hydrazine is. When you look at the practical uses, it really is amazing stuff. That is until you get anywhere near it. You really shouldn't be anywhere near hydrazine for a lot of reasons. First off, it's highly explosive. If you think back to the German plane that was the first practical use of hydrazine as rocket fuel, they actually had more pilots die in explosions in the experimental trials for that plane than they actually had shot down in service. Hydrazine can also heat itself upon absorption, and for this reason it can actually burn your skin if you make contact with it. Hydrazine is also extremely toxic, and if ingested orally or absorbed through the skin, has a whole range of negative side effects. Damage to your internal organs, your nervous system, cause seizures, all kinds of nasty stuff. Extended exposure can kill you. It's also known to be carcinogen, and it's been proven to cause lung cancer. It's for all these reasons that hydrazine is generally handled by hazardous materials personnel, and with a large number of safety and medical precautions in place. If you think about it, to some degree, our world is shaped by hydrazine and its products. They're on our cars, they're on our walls, our ceilings, and more. It's not hard to see why this wonder chemical is everywhere. It's cheap to make, to clean up after, and it has just the right properties so we can use it in just about anything. That's all there really has to be said. This has been Hydrazine.